Welcome to another MicroBIM Fire tool video. This video covers the tools within the Auto Design ribbon. Let's get started. In order for us to use the Auto CS, BC and Exp Spacing tools to create sprinkler layouts, we need to first have spaces within our model. Using the Space Analysis tool, we can copy spaces from a linked file and populate them within our model to create these other sprinkler layouts. Simply clicking the tool and following the prompt in the bottom left corner, we select the architectural model. This will then copy the spaces for this floor and populate them within our model. You can see here that these tools have been created. Now, if for whatever reason a space is incorrect or the architectural model changes, we need to use the Delete Spaces tool within MicroBIM Fire to fully and completely eliminate these spaces. Simply using the delete function within Revit, the keyboard shortcut, will not work. We need to delete the spaces fully. And to recreate them, we just repeat the step before. Now that spaces have been created within our model, we can use them to start our sprinkler layouts. Selecting the space allows us to control the layout in different rooms and different hazard classifications. In this case, we're going to do two different layouts for these two different rooms. Selecting the space, navigating to the MicroBIM Fire ribbon, and clicking on the Auto BC Exp Spacing tool will give us this prompt. The first important detail to make sure is correct is that the architectural model or the link model that you copied spaces from is nominated in this drop down, making sure that that is correct. Next, we select the sprinkler family from the list of families within our model that we want to populate the spaces with. In this case, we're going to choose the below ceilings type here. Now the next portion of this window allows us to control the hazard classification, the coordination of the sprinkler in each of these spaces. Calculating the sprinkler just means that we're populating the space. Coordinating the sprinkler takes into account the other elements within these ceiling spaces to avoid clashes. The spaces column identifies the spaces that we've selected in the background below. And the hazard classification allows us to change the hazard classification depending on the type of room that we're in. For this purpose, we're going to do two alternative layouts to see the difference. We save the changes and the tool will run. Nominating to coordinate the layout will take a little bit longer than normal. If you are doing a preliminary design, you may not want to select this as it will take that little bit longer. So we can see here that our layout on the left is our ordinary hazard layout. Dimensions are automatically populated and the spacing is compliant. We'll repeat the tool on this side with non-coordinated layout just to see the difference. And you can see that the clash is created, but it is still compliant in spacing. Similar to the below ceiling sprinkler tool, to nominate areas for CS spacing, we repeat the process. We select the spaces that we need to complete the layout in. We select the Auto CS Spacing tool and we get this prompt. We check the link, we nominate the sprinkler type, and the hazard classification for CS is light hazard. and we specify the difference from the slab above or the soffit to the sprinkler deflector. In this case, we're going to go with 200 mm. Our ranges will be hard up to the soffit, and we save the changes. Checking our spacing in a floor plan that doesn't hide these sprinklers, and we can see here that the CS layout has been generated. Now we may be in a situation where spaces are not available within the architectural model. So we're going to delete this one to simulate this scenario. So if we don't have spaces within a model, we can still use the tools to create CS and below ceiling sprinkler layouts. Selecting this to create the BC or exposed spacing, we follow the similar steps as before, making sure that our sprinkler is the correct sprinkler, that our hazard classification is correct, and nominating whether we want to coordinate the RCP or not are the same as before. But when we don't select a space, we get this button at the bottom of the window. Pick a point in a space to place sprinklers. This will nominate an area enclosed by walls or structure to create this layout within. If we click that button and hover over the zone here and we click, it will read the space with the walls bounding this area and still create the layout. And you can see in the background here that it's completed this tool. Likewise, we can still do the same tool and run the same function with the CS spacing. Again, nominating the link model, the sprinkler type, the classification, and the distance from the deflector. We can see here that those heads have all been populated within that space. So we don't necessarily need to rely on the architectural model to give us spaces in auto for our auto spacing sprinkler layout tools to work. Once we've completed the sprinkler layouts within the spaces we need to, the next step is to create ranges. We need to draw ourselves a main down the corridor, similar to here, the 65 mm main, and then select the auto piping tool. After that, the tool requires us to select the main and then the sprinklers that we need to or are requiring to connect together, and then we select finish. A prompt will appear where we can use this button, update, to see what the auto spacing tool is going to do. We can see that the pipes that have been generated here are the ranges that are going to be created. We can manipulate these here up and down or side to side depending on what requirements we have. For this, we're going to keep them the same, directly over the CS heads. And we confirm. And those ranges are created. Looking in a 3D view, we can see that the ranges have been created at the point of the CS and have been created at the right level, noting that there is a beam here, which is what this sprinkler and range have been nominated lower. Other great tools within the Auto Design ribbon include T to tap and tap to T. As we know, the routing preferences of pipe styles determine the connection types. If, for example, you're using a tap type range, but want to use a T at the connection to the main, we simply select the connection, and using the tap to T function, we can swap that around. We can do that, and then we can also swap it back again to get the required connection if it's the opposite. After using the Auto Connect tool, you may find that some of your feeds are in the wrong direction and your taps are being created on the wrong pipe. For this, we can use the Rotate Taps tool to swap the direction of the connection. Clicking on the Rotate Taps tool, we select the pipes that are connected and where the connections we want to swap. After selecting, we click Finish. And you can see here that the pipes are being changed to the other direction, the pipes split and the pipes here connected. We can repeat the tool to do it in an opposite direction. Select Rotate Taps, select the items, and we can see that that's completed. Once we've populated our ranges, the next step is connect all of our sprinklers and pipes together. We can see here, if we check in section, that our range has been created up here, close to the soffit, in relation to our CS heads. And extending the view further allows us to see that our below ceiling heads have been populated at the ceiling level. Turning to a 3D view, we can see that our ranges in our main, plus all of our below ceiling and concealed space sprinklers are in our view. Navigating to the Auto Design ribbon and selecting Auto Connector will bring up a prompt window. From here, we select the options and choose between the different connection types to connect our sprinklers and pipe together. In this case, we're going to connect all sprinklers from hard pipe. We nominate hard pipes. If we were to nominate flex pipes, we would be able to select the type of flexi and the connection fitting before the flexi at this point. We nominate the direction of the pat as a primary condition at this point, and we can determine whether we need to select a certain height that we want our arm to rise up, maybe within a beam space if required. Any sprinkler that is aligned vertically with the pipe is nominated connection types here. For a car park, we may select that all sprinklers to snap to ranges, but in this case, those in close proximity to the ranges that we generated will connect directly to it with a pat, and those at lower level will have droppers to them. We can nominate here to extend the pipe past the last pat if required. After we've nominated all the connection types, we select OK. We highlight all of the elements that we want to connect together and click Finish. This will generate the network required, and we can see that all of our elements are connected together. Paps and connections down to our heads. The Auto Connector tool can also be used for a small scale connection. See here how the range and the main aren't connected. Selecting the Auto Connector tool, ensuring that the hard pipe options are selected. We pick those two and run the tool, and it will connect it. To connect your below ceiling sprinklers to your ranges using flexible connections, we suggest using the Connect Pipe to Sprinkler tool. Please refer to this video for more details.